This is the section that you learn a lot of formulas and it takes lots of practice. Integration is kind of complicated, and you have to remember that it's not like the derivative. You can't integrate everything the way it looks. With the derivative, you had a product rule and you had a quotient rule and you had chain rule, and it pretty much allowed you to take the derivative of any function you've ever seen. However, integration is complicated. You can't work backwards as easily. So sometimes you have to put things in a different form. The Calc 1, this course, doesn't cover all of the integration techniques that you'll need. If you go further in calculus, you'll learn a lot more in the next one. So this video here is only going to cover a few things that you might see on the assignments, but you really need to practice integration. There's a lot of practice problems in StudyForge and videos, Khan Academy, and Patrick JMT. There's lots of places where you can get extra practice. You really need to be great at integrating before you can be successful in the rest of segment 2. So having said that, I only have a few examples here. They are ones that require you to simplify because we cannot integrate this the way it looks. Again, there's no quotient rule, there's no product rule, there's no chain rule. There's a power rule, and that only works when you have like an x to raised to a power. And there's, the trig formulas have their own antiderivative and the natural log, but they're all separate. They all have to be all by themselves. They can't be multiplied to anything or divided by anything. So as soon as you see a quotient or a product with inside an integral, like as an as an integrand, you're going to have to do something with it. And the next section is going to talk about substitution, which is one of the strategies you can use. So this one just deals with simplifying a little bit first. So because this is a trig function, you're most likely going to need to use some properties of trig, like Pythagorean identities or just reciprocal properties, things that you learned in pre-calculus. So we need to simplify this first. In this case, remember that tangent is sine over cosine and secant is 1 over cosine. So really, we can replace this. You can multiply by the reciprocal here and make this the numerator times cosine over 1. Those cosines cancel. You're left with just sine. So this is really the same thing as the integral of sine. And now, because it's just sine all by itself, nothing else, nothing being multiplied to it or divided to it or anything like that, that has its own formula. And I totally have a typo. This is negative cosine. Because remember, this is the derivative. So this is the derivative, and this is the original function. So you can always check it and take your antiderivative, take your answer, and do the derivative of it. The derivative of cosine itself, without the negative, derivative of cosine is negative sine. So in order for this to be positive, you have to have a negative in front of it. So my bad, I have a typo, I'm so sorry. Okay, next one. So again, this is a quotient. We're going to have to simplify this first. We can't integrate that the way it looks. So let's simplify. All right, so what do you want to do here? Let's play around with the sine and the cosine. And this one, like some of you might have been thinking, let me go here real quick before we do it this way. You might have been thinking this, 1 minus cosine squared, but there's not much you can do with that because the denominator has subtraction in it. We can't simplify this any further. So this doesn't really help us. If it was the other way around, let's say it was sine squared over cosine. Well, now we can do this, 1 minus cosine squared. And because you have one thing in the denominator, you're allowed to do this and split them up. That would be okay. And then you would end up with, this is going to be secant, that has its own formula, and then this will be cosine. That has its own formula. So this would have been okay if the sine squared was on top, but because it's on the bottom, we're not allowed to split it up like this. It's just not algebraically equivalent. So we have to try something else. And in this case, let's write it as two signs being multiplied and split that fraction up into two pieces. Because if you start to memorize your formulas, if you're an AP student, you better start memorizing these integration formulas, because cotangent times cosecant, that's one of the formulas. So this is really the integral of cotangent times cosecant, which is negative cosecant. Okay, let's do one more. Evaluate the integral of e to the power of 6 times the natural log of x. This course likes to throw problems like this at you. So if you've seen any more of my videos, you'll probably see something look familiar. So we need to simplify this first. If it's just e to the x power, we're good. If it's e to the something power, no good. So we need to deal with this, because this is equal to this. No big deal. But as soon as you have something else besides x here, you cannot integrate the way it looks. So let's deal with that 6 times the natural log of x. So this is the thing I said you've probably seen before if you've seen any previous videos of mine, because this course likes to do this to you. It likes to remind you that when you multiply something to a log, it's actually the exponent to the argument. And now if you take this, it's technically the same thing as e to the power of natural log of x to the 6th power. And remember that e and natural log cancel. They are inverses of each other. They wipe each other out. Here's why. So side note, this is equal to, I have it equal to a question mark. If we want to know what this is equal to, then put an equals question mark. And remember, if you want to undo what's happening to an exponential function, you have to redo it, or I'm sorry, rewrite it using logs. You can take this and rewrite it as a log. With a base of e, the answer to the log is the exponent, and then the exponent here comes over here. Oh, I'm sorry, I said that wrong. This is the exponent. Let me back up. Love it. I love when you mess up in your recording. Let's start over. This is our base. The answer to the log, I said it the right way. The answer to the log is the exponent. So this is what the log is equal to. Log equals this. And then this is the argument of the log. So we're going to rewrite this. The base of the log is the base of the exponent. The exponent is what the log equals. So this is log with a base of e. The exponent is what the log is equal to. This is the argument of the log. Okay, so now log e, log base e is the same thing as the natural log. You don't ever see it written as log base e. It's like a kindergarten way of looking at it. It has its own symbol. And now if you just look at this statement right there, it's property of equality. Those have to be equal because that's what the equal sign says. That question mark has to equal x to the 6th power. So over here, e to the natural log of x to the 6th power is the exact same thing as saying x to the 6th power. So this integral that we started with is really saying that it's the same as x to the 6th power. And now you can use the power rule. The power rule is where you add 1 to the exponent and then you divide by that number. So if you add 1 to 6, you get 7, and then you divide by 7. So x to the 7th over 7. And then because this is an indefinite integral, there's no a or b here, we have to remember to include that plus c. Don't forget that. Okay, and like I said, these were just simple random ones. I don't want to say simple, but random ones that I saw from the assignments that I thought you might like to see examples of, but you need to do plenty of practice with integration. Power rules with exponential equations, trig functions, memorize those formulas. And 505, we'll talk about substitution. Same thing, you have to do lots and lots of practice to get good at this.